went away.
Went away. I dwell in darkness without you and it went away.
I can't decide if it would be nice to give you the year of the movie because maybe that's too big of a hint. I don't know, but then again, how many of you even know movies from this late back? Let's talk about things that I hope did not go away from your memory. These are prerequisites that you're expected to know from the intro course. As we go through these things, if there's something where you're like, not real comfortable with that, that's okay. It doesn't mean you're in the wrong class. There are some videos here that you can go see on my webpage that talk about it in detail for the intro course. And it might be that as we go through it quickly, you'll say to yourself, okay, I need to pause and think really carefully about this. For example, the first two terms, standard deviation of the data and standard error for a statistic. Very similar names. In fact, deviation or error, those words are kind of interchanged. The rules are not as clear as I wish they were. But the idea of, are we talking about how spread out the data is, or are we talking about how accurate our statistics are? Keeping those separate matters a lot. For example, if you have a little bit of data, you can estimate both of these. If you get more and more and more data, this won't change. It'll get more accurate. This one will drop to 0. Because as you have more data, you have more accuracy in being able to estimate exactly what those statistics should be to get them close to the parameter. In the intro class, this was the difference between sigma and sigma over square root of n. In this class, we're going to see a lot of times where data is spread around the regression line. This is how far does the data spread. This is how accurate is our regression line. Another important term you should know is what is the null hypothesis, and how that null hypothesis always has an assumption of being equal. Equal means there's no difference between the two categories, or knowing what category we're talking about doesn't really matter, that sort of thing. So the null hypothesis is what we assume to be true. And along with that is an understanding of the p-value. Think of the p-value as supporting the null. A large p-value means the null hypothesis seems reasonable. You can't prove it's true, but it does seem to be okay. Small p-value? No, that null hypothesis must be wrong. And so we look at the alternative, which is the opposite of whatever the null is. So in that vein, you're expected to be comfortable with what do you do when you reject the null. Small p-value, we can now say the null is definitely not true. There is a difference. Something is happening. It does matter the category or where we are in the regression line. The alternative here is if we fail to reject, that's because we had a large p-value. Now we can't say the null is wrong. We also can't say the null is right. And so we just say, well, there isn't enough data here to suggest that this matters. In our class, we're going to use this a lot to say, here we couldn't show that this variable is helpful. Here we could show that looking at that variable matters. And we will get more into that, but for right now, you should at least have an idea of we create a null that we assume is true. The p-value says, can we back it up? If we can't, then we reject that null, and that shows us that we have found something interesting, exciting, different than what we assumed to be true at the beginning. This is hypothesis testing. The flip side, of course, is the confidence intervals, and that's where you make a range for where could the parameter be, what is likely, and it's very similar to hypothesis testing. In fact, statisticians will sometimes argue about which method should be used more frequently. I'm kind of hoping confidence intervals win out, but we use the terms of being 95% confident, not that there's a 95% probability, and you do need to know the right kind of wording that you can or can't use. You also should be comfortable with when do we use Z versus T. Z requires knowing that standard deviation. We talked about that in the last video. So we're going to use mostly T's in this class. And if you understand the difference, that will make sense. There's a couple different tests that you should feel comfortable with. Testing one mean for a specific value or for a confidence interval, which is the most likely way that we will do it. You can test two means, and that might be independent or matched pairs. The difference between those matters, and you are expected to understand and recognize when it should be matched pairs. The good news is all the details about those equations we're not going to really emphasize because the computer will do it for you. More importantly is to understand how does a hypothesis test work, how do you interpret confidence intervals, and how do you figure out which kind of test we're talking about. And a lot of what we're going to do is going to be regression. So in the next video, let's talk about some regression ideas that you should probably already know.